Good afternoon, everyone. This is Elisa Baum. I'm GridGain Systems Director of Product Marketing. We will begin in just a moment, but I need to conduct a bit of housekeeping. First, could you please raise your hand using the hands icon on the GoToWebinar control panel to let me know that you can hear me? So if you wouldn't mind letting me know if the sound is coming through, that would be great. Okay, good. I see that people can hear me. Next, during this presentation, you will be on mute, but should you have any questions at all for the presenter, please go ahead and enter them into the questions part of the GoToWebinar control panel. At the end of the discussion, we'll take time to answer as many questions as possible, and those that aren't answered will be followed up with a blog post on the GridGain.com blog. In addition, I'll make sure that everyone has a copy of both the recording and the slides after the show. And with that said, I'd like to introduce today's speaker. This is Akmal Chaudhry, and he is GridGain Systems Technical Evangelist. And with that said, I will turn the floor over to Akmal.
Okay, thank you very much, Alicia, and thank you very much, everyone, for joining today. So good afternoon, good evening, good morning, wherever you are in the world. So for me, it's just gone 7 p.m. in the evening, London time. So let's get going. So the focus of our webinar today is meeting the challenges of fast data in healthcare with in-memory technologies. So we'll focus on some of the characteristics, some of the needs of healthcare today, and some of the technology requirements. And we'll look at some case studies as well, some customers who are using in-memory technologies, Apache Ignite, specifically GridGain in some cases, and I will discuss the kind of differences and similarities between the two very shortly as well. And we'll walk through, and we have an hour scheduled for this, so it's possible, depending on the speed and the pace, hopefully we'll finish a little bit early and leave time for questions as well. Okay, so in terms of agenda, then fairly simple and straightforward. So we will really do a brief introduction in terms of what is Apache Ignite. Then we'll drill down a little bit into looking at some of the requirements of fast data. And by fast data, we are really talking about analytics for smaller sets of data, what we would traditionally call big data, but perhaps data that are being streamed, that we are receiving in real time. We need to be able to do some processing of that. Sometimes we can combine that fast data with big data as well. So data that perhaps is stored on another storage mechanism rather than being streamed in, and we may want to combine the two sets of data together to be able to get some analysis and some insights. We'll again discuss that a little bit later on. And then two case studies. We have one which we'll talk in a fair bit of detail. This is ETherapeutics. Okay, so this is fairly well documented on the GridGain website. And then we'll talk about another customer very briefly as well. They are doing some work using Apache Ignite and some of their requirements. And although it will be a little bit shorter, we're hoping that in the future we'll be able to expand upon this particular customer's requirements, the kind of things that they've done with Apache Ignite, and we'll write that up as a detailed case study as well. Okay, so if you want to see just one slide, what is Apache Ignite? I think this provides a very succinct summary. So it's an in-memory computing platform. This comes from its in-memory data grid sort of historical background, if you like, but there is this durability we talk about. So the ability to persist data, store it beyond the lifetime of the process that created it. Strongly consistent because it supports this notion of transactions, and these are ACID transactions, what we traditionally associate with database management systems: atomicity, consistency, isolation, durability. And then this high availability. So performance and scale come from this. These are the sort of two things that really were the reasons for the development of Apache Ignite. And again, we'll talk a little bit more about that later. And increasingly, the addition of some additional capabilities that beyond the kind of development of just an in-memory data grid. So SQL support, for example, very important today because lots of tools, lots of database systems still use SQL. It is still a very, very popular language, a huge skill set available in terms of developers. And again, many tools that can plug directly into this, and you can do this through JDBC, ODBC, or directly programming through the SQL API. Key value, we'll talk a little bit about that later on as well. Okay, so this is part of the, one of the more mature parts of the product, which originally came as part of the in-memory data grid, and many different types of processing APIs, of which we'll discuss a few of them today. Here is a very high-level view of the platform itself. What I guess you could say is a sort of 30,000-foot view or 50,000-foot view, how you want to say it. So memory-centric storage is at the core of this. Briefly touched upon that previously. Ignite supports this native persistence, which we see down in the bottom left-hand side. Okay, so it's something that can be enabled very easily. It allows you to store data on disk, and again, persist data beyond the lifetime of the process that created it. But equally, third-party persistence can also be used. So if you have investment, for example, in a significant investment in a relational database management system, or you are using HDFS or even NoSQL technology, then you can use those as well. And then on top of the memory-centric storage, then we have a number of these language APIs, so SQL, for example, and then additional components, things like the compute grid, which we'll talk about a little bit later on, streaming, which is again very important in certain applications. We'll look at that very briefly later on. Things like machine learning as well, very much the flavor of today, and has many applications, of which healthcare, I think it has very useful properties that would be extremely amenable to many different types of healthcare problems. And then, of course, lots of different verticals. Ignite is used in a wide range of industries and verticals, from financial services, travel and logistics, e-commerce, IoT, of which we'll look at one particular sort of area for healthcare a little bit later on. And of course, lots of users. So this is just a small sample of some of the users that are using this particular technology, and as we can see, we've got a very good sample from various verticals and various sort of industries. Notice that in the middle, at the bottom, we've got pharma and healthcare. So ETherapeutics is one of these, and we'll drill down into them as a specific case study very shortly. Okay, so as part of the research that I did looking into this whole area of healthcare and some of the needs and requirements today, there is a wonderful report that I came across published by the Stanford medical school titled Harnessing the Power of Data in Health. And this was published this year, not very long ago, and it does a very good summary and analysis of some of the requirements for healthcare in the modern world, and some of the problems that we have, and how solutions such as big data, fast data, modern technologies can help us resolve some of these major issues that we have. And so increasingly, the observation there is for personalized therapies. So things like oncology, for example, the study and treatment of tumors and cancers, neurology, disorders, nervous system, cardiology, disease and abnormalities of the heart. These are very prevalent today. A lot of modern sort of problems, health problems that we have today are part, I guess, of modern living. But there is a great opportunity now to develop tools that are far more collaborative in terms of being able to patient care. Doctors, nurses, ambulance drivers, all of these people can utilize these technologies far more efficiently. Genomic sequencing, very important as well, because now we can discover the genome of an individual, and we can then develop treatments that are targeted specifically at a person. And again, things like tumors, drug discovery, which is what ETherapeutics is involved in, and then coming up with solutions and answers to help with a lot of these rare and complex diseases that we see in the modern world today. So one of the things that Ignite provides is distributed storage and the ability to really process this data using this distributed key value store. So now with key value, of course, we have perhaps a system generated key, but the value could be anything. And increasingly, we are seeing the adoption of these electronic health records around the world in various countries. So here in the United Kingdom, for example, we have the National Health Service, and they are utilizing these types of electronic health records. So this keeps the history of a patient. So there is fixed data, for example, date of birth, and then perhaps some type of national health number. But then there is variable data in terms of the doctor's notes, for example, or the kind of medical treatment that they received. And then there could be other complex types as well, things like X-ray images, for example, or MRI scans, these type of things. Now, potentially these records can be quite large, but the thing is, once we've created these and once we have them in a system, it allows relevant people to access this information based upon their role, and it's consistent, and things are far easier to fix rather than using paper-based systems. So where potentially we could lose some information as we go from one sort of paper-based system to another paper-based system. So Ignite is very agile in this space. Again, gives us the ability to store lots of complex types. And again, we have lots of strong capabilities in terms of what we can do with that data. So we can query it using SQL, we can do computations. Transactions are very important. So this ensures the consistency of our data. Again, very similar to the way that modern database management systems work. So the other area that really stood out from this Stanford report was this notion of patient interactions, that we can do far more today in terms of these health wearables. Pedometers is a good example. Or if you look at some of these Android and iOS type devices, that we have these apps now that allow us to do a lot more in terms of monitoring our own sort of personal health. And it's become very much the case that, this Internet of Things allows these sort of capabilities. That data can be collected, it can be streamed in, and again, it allows medical providers to create these personalized sort of experiences for the individual patient. So in general, then, Apache Ignite can be used to improve responsiveness for self-service and protect existing health information systems that may get overloaded for other types of applications. This is for most patient self-service through custom apps or APIs, and we can see great examples of these already on the type of these smartphones that we own. Here's an example of a kind of an architecture, if you like, that at the most lowest level, we are using these kind of embedded real-time operating system, and this is 100% Apache Software Foundation. Then we can do data collection and enrichment, using streaming technologies such as Apache Flink or Apache Spark, and then we can use Ignite to do a lot more. So it acts as the in-memory computing platform. It has the application APIs, and we'll look at this a little bit more detail further on. The third area that I really picked up from this report from Stanford was this idea of using predictive analytics and machine learning. Okay, so this is these kind of ideas, especially around machine learning, data science, have actually been around for a very long time. The difficulty always has been the lack of processing power. Complex models can take a long time to evaluate. But the thing is that now we have that processing power available. We can do diagnosis much faster. We can treat diseases much faster, and we can detect these diseases earlier. And that saves a lot of cost further down the road in terms of actual cost of healthcare, because if we can nip things in the bud, we can treat things earlier on, and that's far better, both in terms of the patient's health and, of course, later on in terms of the overall cost of the healthcare that has to be spent. So Machine learning, great in terms of looking at individual patients, the kind of lifestyles, their diet, their general condition, what medications they're taking, for example, and these things can feed in to get a much better idea of the of potential risk further down. And this allows us to pick out these emerging health sort of concerns much earlier. And again, what this boils down to is this whole idea of personalized treatment, personalized medicine, which is becoming far more prevalent today. And this is a great move, really, because it allows the medication, the care to be treated and targeted towards the individual rather than providing a kind of a general service. If we look at what Ignite then offers in this space, so I briefly touched upon the machine learning grid somewhat earlier, and this is something that's available today, gives a lot of support to sort of things like dense and sparse algebra and k-means, regressions, decision trees, all these kind of things that if you have worked in this space will be very familiar to you. In terms of application interfaces, well, obviously Java, but other languages such as C++ as well. And it's possible to use things like ODBC, JDBC to be able to use other types of languages as well. Multiple language support. One of the key, I think, and important points, again, is that because Ignite is a distributed platform, it can run across a cluster environment. Using these algorithms in a distributed way provides a lot of benefit as well. And these are algorithms that have been specifically rewritten, okay, for the use within a clustered environment. So it's perfectly possible to find libraries that will do this, but they are kind of black boxes, if you like. They will run on just one machine. Ignite, with the libraries that are provided as part of this machine learning grid, will allow and enable these algorithms to be run in a distributed fashion. That makes full use of the clustered environment. It makes use of the parallelism. And again, that has great benefits. And again, when we discuss ETherapeutics a little bit later on, we'll see that this provides tremendous sort of speed up in terms of the kind of work that they are trying to do. Okay, so as I promised, there's a couple of case studies then, and let's drill down and have a look in a little bit more detail. So we'll start with the first one then, which is ETherapeutics. So this is a company founded in 2003, and it's based in the United Kingdom, drug discovery and development group. And they've been working on a number of things. So treatment for biocomplex diseases, cancer, for example, neurodegeneration, so things that attack the nervous system, for example. Examples would be like Parkinson's disease or Alzheimer's, for example. And then looking at cancer immunotherapy. So this is really use of the immune system itself, the body's own sort of defenses, if you like. How can the body be able to attack some of these cancers? And looking at the level of sort of molecules, if you like. So they're really trying to find ways to be able to treat and target specific cancers, being able to develop these therapies to help the patient recover to the best health possible. Here's a kind of a summary in a single slide. We'll look at some of these areas in a bit more detail shortly. So the key problem that they have is that a lot of this analysis, proteins, molecules, that influence the kind of diseases that we may find ourselves with, they need a better way to do the analysis, okay? So it takes time, and it takes, because parameters, algorithms, these things are not particularly amenable to sort of single use, if you like. So the key problem here is how can we take what we already have and be able to parallelize this? And this is the kind of problem that they were encountering. The other thing in terms of the solution then that Ignite offered specifically was that because it can use the processing power of the cluster, all of the resources available to hand, it can provide significant speed up. So in this case, nearly sort of 2 orders of magnitude faster than the existing environment that they had, the existing architecture that we're using. And the other thing is that, again, the key points here is that being able to do these kind of discoveries and being able to run these models, simulations, and do the research that can provide results in sort of minutes and hours rather than having to wait days and weeks, again, it provides considerable benefit as well, both in terms of resource utilization and being able to do these kind of drug discoveries, if you like, much, much faster. And again, we'll look at this in a bit more detail shortly. Okay, so the first thing that they faced, there's a couple of challenges. So the first challenge, network pharmacology. So here, what they're trying to do is identify and analyze specific network of proteins associated with a particular disease. And then they're looking for multiple intervention points as to how to be able to help. You know, what can we do? What is the sort of, you know, if these are impacted simultaneously, how can they disrupt a network of proteins? So the goal here is to seek drug molecules with the best overall impact on the protein network. Okay, and that's kind of fairly low level, but it requires a lot of effort and a lot of time and a lot of sort of processing power to achieve this. Slightly more related to this, but a bit more in terms of the kind of analysis that they need in is the actual computational power. So as I mentioned a little bit earlier on in the summary slide, a few slides ago, so the single analysis is fairly straightforward. Doesn't take a lot of time. But the thing is that this is not work done in a lab, okay? It has real application. So with the ETherapeutics approach, what they need to do is a large number of analyses, multiple parameters and assumptions, very compute intensive, okay? And therefore, you really need a mechanism to be able to spread that workload out, use something like cluster computing, parallelize the operations, make full use of the resources that you have to be able to process this data much faster. And in some respects, if you're familiar with the way that machine learning works, for example, often it's changing a set of parameters, or it's like, you know, you want to be able to run a model, and then within a certain threshold, once it's reached that, you're able to stop. But it's a fairly complex problem. And here they're doing sort of very similar sorts of things. Ideally suited to this then is the Ignite compute grid. So this provides effectively the parallelism that they were able to use for this particular problem. The way this works is, if you're familiar with things like MapReduce, fork join, for example, then this works in a very similar way. So typically then we've got some work coming in on the left-hand side, C equals compute. C is a task. The task is broken down into two jobs here, C1 and C2. And in this case, the reason it's done that way is that our Ignite cluster on the extreme right-hand side actually has just two servers. So the work is split equally between these two servers. It's run in parallel. The results are sent back. These are combined, and then we're able to send this result back to the client. Now, assuming these two servers on the extreme right-hand side are equal sort of capability, equal power, equal memory, and so on, then in theory, we're able to do the work rather than running it on one machine. We can do it in half the time. And you can see that adding additional resources, adding additional servers, allows us to be able to process and break that task down into smaller components. We're able to run those then in parallel, and then again combine it and send it back to the client. So again, utilizing the resources of the cluster. So this is a classic and very useful way to be able to do complex problems. And again, this is a solution that ETherapeutics found was very amenable to the kind of problems that they were facing. Okay, so what kind of benefits did they get overall out of this? Well, now you'll see I mentioned GridGain here. So GridGain is the company behind Apache Ignite, but offers some support, some additional enterprise capabilities as well. But the Apache Ignite is open source, downloadable, okay, from from the Apache Software Foundation, and we'll have a look at some of the resources very shortly. So they chose GridGain to power this new pharmacology platform we talked about previously. Initially, starting off fairly small, 20 nodes, commodity server. Okay, so again, this is useful because it's kind of off-the-shelf hardware. You don't need anything special. And one of the nice things about Apache Ignite is it will run pretty much anywhere. Okay, so it will run on a laptop. It will run in a cloud computing environment. It can run in Kubernetes, you know, these kind of Docker and container environments. And it will suitably configured. It can run in fairly constrained environments as well. Over time, that had grown to 100 nodes on 5 servers. And if you were a little bit sharp-eyed and you saw the summary slide that I showed a little bit earlier on the right-hand side, I actually showed a graphic with this 100-node 5-server sort of summary. As I mentioned a few moments ago, so they've achieved nearly 2 orders of magnitude speed increase over the existing non-parallelized environment that they used to have. And that, again, gives them considerable benefits in terms of both getting results back faster, and then that allows them to target areas for future research much faster. It enables them to use the other resources that they have, both in terms of people and money and time, more effectively and more efficiently. Okay, so this is a good quote from Dr. John Ray, Head of Discovery, Informatics, ETherapeutics. So very quickly, what he's saying here is GridGain has allowed us to complete in just a few hours or even minutes analysis projects that used to take weeks. Just as important, we've been able to launch initiatives that were simply computationally infeasible before. So again, the focus here is that how much faster it's been able, Ignite has helped them to achieve their goals in terms of being able to process data much faster. And then again, if there's a particular dead end or a research field that looks as though it's not going to yield interesting results, they can identify that very early on and not waste their time. So it's effective use of resources that they have. And again, for a business in this area, I think cutting edge type of stuff, it's very, very important to be able to move forward as quickly as possible. Second thing, benefit number 2, increased productivity. So disease biology specialists are not computational informatics specialists. I mean, this is the key thing. And this is not unique to this particular industry. You know, we can apply this logic to many other verticals and very other industries as well. So what they've been able to do then is to build a web-based interface that connects to a microservice. And Ignite actually offers a service component as well, which can form the basis of a microservice architecture. And we have some content and material on the GridGain website that covers this. What this allows the scientists to do then is to run analyses without having to work from a command line. Okay, so they can use a high-level interface to do the work that they need to do. And again, there's no need to consult with these sort of IT specialists, if you like. Okay, so the disease biology specialists can focus on what they want to achieve and what they want to do using the high-level technology, the high-level interfaces, without having to worry about getting down to a very low level in terms of interacting with the system. The other thing is that multiple biologists can work on multiple projects. This is very, very useful. Again, accomplish far more in less time, and that's the important thing here. And the final point there is that over a period of time, I think it's about 18 months or so, this company has been able to run something like 10 concurrent discovery projects with just a very small team of scientists. And then what they discoveries, if they find any, these can move to the sort of a testing phase, if you like, much faster. Or if they find there's a particular dead end, they need not worth pursuing the research in that particular area. Again, that's something that can be identified earlier on, and they don't waste their time pursuing that. Final kind of benefit, this is a little bit broader, so peace of mind. Now, GridGain is based on Apache Ignite. So out of the box, Ignite offers many, many capabilities. Now, obviously, GridGain need to pay my salary, and they need to there's a business to run. So there are a few enterprise features that they provide. And again, in terms of consulting, training, support, and other capabilities as well, and other requirements, these are available as well on a sort of fee basis, pay basis, and if you need those kind of capabilities, then please do get in touch with us, and we'll be happy to discuss those with you. But the key thing here is the strengths of the Apache Software Foundation. So Ignite is a top-level Apache project. It's received a lot of traction over the past couple of years. The community is very lively, and again, the point here is that being the Apache Software Foundation, which has been long established and has provided some great reference implementations. So go back in time and look at some of the early days where they were doing things like Apache Tomcat, for example. Now, the reference implementations that came from the Apache Software Foundation were exactly that. The thing is, these were so robust and so reliable, people started using these in production environments. So there is a great history and a lot of credibility to the work that the ASF does. The other thing is the longevity. Of course, being an open source project, having a great community around it, having a lot of activity around it, this again provides a lot of confidence in the technology going forward. This is, I think, important in today's world, particularly where many companies are engaged in, venture capital, and some of those can end up in a sort of dead end, and those projects may die. But this approach, doing it through the Apache Software Foundation, was a great move by GridGain to donate the software. It puts it out into the community, and as I said, out of the box, Ignite offers many advanced capabilities, and it can be used standalone. There's some enterprise features that you may require in an environment, but those are things that we can discuss offline. Okay, let's move on then to the second case study. So this is a primary preferred provider organization in the United States. So it's a company founded in the 1980s. Now, unfortunately, we can't name them at the moment, but this is hopefully a case study that we'll be able to build and write up and discuss in more detail in time. So the system of healthcare is a little bit different in the United States than it is in the United Kingdom. In the United Kingdom, as I mentioned earlier on, we have this thing called the National Health Service, which provides free healthcare for everyone. Some people choose to take out insurance and take out private medical care, but ultimately many of the sort of serious health conditions, if you like, a lot of these serious medical conditions, cancer, Alzheimer's, and others, end up being treated by the NHS. I mean, this is because they have a lot of resources, have a lot of expertise available. So this particular PPO has lots and lots of doctors and hospitals which are in their kind of preferred network. Being part of the preferred network, obviously insurance claims then are paid at the highest level. It's possible to do it out of this particular network as well. I mean, this is something that I think if you're based in the United States, you'll be familiar with how these schemes kind of tend to work. This company also has many millions of customers across the US, and it's involved in many millions of insurance claims being processed on an annual basis. So it's a large amount of data to deal with. There's many different aspects to this data, so it's a fairly sort of complex set of conditions that this company is facing. Now, in terms of the kind of specific challenges that they have, and because we've got a little bit less information here that we can share, what I've tried to do then is to give you a bit in terms of the benefits along with the challenges here as well. So the first challenge is really consolidation. Now, they're using a competitor in-memory data grid already. This is built on top of a custom facade. And what they're trying to do then is replace this existing system with Apache Ignite. And there's kind of two main reasons, really: consolidation and to save costs. Consolidation because they see the benefit of Apache Ignite and the open source nature of the product. It's robust, it's reliable. The fact that GridGain backs this up as well with enterprise features if they need them. And again, in terms of cost, this is, I think, very important. So licensing from sort of the Apache Software Foundation is extremely generous, and therefore, that helps a lot. The open source community has changed significantly. So many years ago, when I started out my career in IT, it was very unusual or very rare to see the adoption of open source technology in sort of significant projects. Over time, as this has become a very prevalent model of development, and we see a lot of communities being developed and multiple projects being released, then things through the ASF, in particular, as I mentioned, have a much more sort of credibility, if you like, and support. Then this has become far more useful, far more adopted throughout the industry, and this again helps in terms of the bottom line, because costs can be quite significant, and licensing costs in particular can be quite significant for a lot of software technologies today. The second system, as I mentioned there, as we can see, it's a web-based application built on a traditional Java Enterprise Edition JEE architecture stack. So the business logic is really built in stored procedures, and it's compiled to an existing relational database. Now, the way that they've architected it is that for their existing requirements, it was reasonable and it was adequate. It meant that yes, processing could be achieved in reasonable length of time, but it did mean that unfortunately the maintenance of the code and maintenance of the application, the ability to enhance it and improve it, became somewhat difficult. So they can't use this approach anymore. It's too difficult. So what they've done is that they are in the process of moving the data to Apache Ignite, and then the next phase of this will be to actually take the business logic from a lot of these stored procedures that have been written, and again be able to move them to an Apache Ignite environment. They also need to improve the response time. Okay, so they feel that this approach, shifting to Ignite, using some of these cluster capabilities and some of the other features and components that we talked about previously, they will be quite beneficial to them. And again, being able to reduce these response times from something like 15 seconds down to a second. Okay, so that's almost kind of instantaneous. Okay. So SQL is fairly important to this customer, and again, Ignite offers very robust SQL capabilities. This year in particular, the data definition language, data manipulation language have been enhanced and improved considerably, although Ignite has supported some level of SQL for a while now. So JDBC support, ODBC support, direct SQL API if you want it, and again, all the benefits in terms of the dynamic scaling, the elasticity, adding additional processing power as you need it, as your cluster, you add additional resources to make it larger, remove resources when you don't need those, additional processing power. Cross-platform capability. So Ignite is written in Java, but there is excellent .NET, C++ support. There is a mechanism available to allow you to share objects between these different language platforms. This is something I looked into a while back and wrote an article on this. And then also, because a lot of business intelligence tools work with SQL, the dashboards, creating insights, charts, graphs, these kind of things, work directly with the SQL, either through the SQL API or using JDBC or ODBC. So this support here is actually SQL 99, just to add that. So all of DDL, DML, things like indexes as well, it's all supported. Okay, so the second challenge here is a little bit more complex. So this is a kind of medical process audit system. It's a claims matching. So in addition to claims processing, a lot of providers need to build patience and want fast responsiveness for looking up billing information and processing payments. So in this particular case, as insurance claims are submitted, they are matched up against other procedures that have already been recorded. And then what this provider needs to do is to ensure consistency. Basically, sometimes these procedures are not coded to a particular way, and therefore they need to be able to recognize duplicates, other problems in the claims, so that there is a level of accuracy and integrity that's maintained. This is very, very important. Information has to be accurate. Claims must be paid on time, okay, but they need to be able to be sure that everything has been processed correctly. So at the moment, the way they process this is offline using a batch process, but a lot of their users now would like to be able to have the information much, much faster. Customer wants to provide the fast turnaround to their users, and the kind of response times that they're looking at is they want to bring the time down to around 5 seconds. Okay, now I've got any questions here. We've got a little bit of time, so let me just show you a couple of things before we dive into the questions part of this. So just by chance, I've got a couple of things running on my machine here, which I can quickly show you. So this is the kind of Ignite dashboard, and I've got a specific application which is available. And let me just switch to the web browser here. Okay, so this is downloadable again from my colleague Dennis Magda's GitHub account. I'll bring this back up again in a few moments. So I have an IoT type of application here. Okay, remember we talked about this in the slides earlier on, that this is one of the areas that Stanford has really identified as sort of key to bringing a lot of this kind of personalized medicine, being able to collect data and help the individual get a better understanding of their overall health and condition, as well as feeding into a lot of research that we see today. So in this specific application, as you can see, I mentioned a little bit earlier on that Ignite can run pretty much anywhere. Well, it just so happens that I'm running it within an IDE. So I've got a very small cluster of 2 nodes here. And let me kind of just see if I can zoom in a little bit. Okay, and then just show you. So we've got this thing here, servers equals 2. Okay, so there's an Ignite node here and an Ignite node here. Okay, and then what I have is this application here. Now you're probably going to be rather underwhelmed because it doesn't actually show anything other than a message that says sensor sample generator is up and running. So what's happening here is there's a Java application here. It's sitting there generating kind of random data just to simulate what could be some type of sensors or some type of devices that are accumulating data, and it's not going anywhere at the moment. There's not, no application is taking that data and reading it. And if we look at this console, I'm running this from GridGain, but this is the kind of web interface to Ignite that allows us to see some information. This is the kind of the dashboard, as you can see, gives us some useful statistics and information. And if we just scroll down here a little bit, what it shows us here is that we've got 2 caches. One called, oops, let me just try and make this a little bit bigger here. One called sensor cache and one called temperature cache. Okay, so think of a cache as a little bit like a relational table. It's a way to, an aggregation, it's a collection. And so far we can see that there's nothing there. So we've got a cluster up and running here, which tells us at the top here, cluster 292B1EE9, right at the top here. It consists of 2 nodes running within an IDE, but at the moment there's no activity. There is an application that's running, generating, simulating kind of some data that's being generated, and nothing is connecting to it. What we have then is this additional application which will take that data, it will do some processing with that, and then we'll be able to see some results. So let me fire this one up. Okay, just takes a moment or two. We'll make this a little bit bigger here. Okay, there we go. So sensor information has been loaded to the cluster. Streaming of sensor samples is activated, and there we go. So what's happening then is that the data, this is now connected to this application that is generating some sensor data. It's taking that data, it's doing some manipulation of that, and it's running some SQL, and then it's outputting this data for us and only showing us the top 20 rows. Okay, so this is a very simple example of how we can set something up fairly quickly, be able to take some streaming data, and Ignite has connectors for a variety of streaming technologies. In an earlier slide, I showed Apache Flink, Spark streaming, things like Kafka as well can be used. But in this case, we're able to apply some logic, if you like, being able to summarize that data or look for particular patterns on that data, and then we can output that in a format. Now, this is not doing anything particularly useful other than outputting the data to the console, but we could, in theory, do some things like machine learning, for example. We could take the machine learning grid, apply some algorithms on the data that's being streamed in. We could keep sort of like the last 10 events or 5 minutes worth of data, do some modeling on that, run some SQL code on that, format it nicely, and then that could feed into, for example, some type of business intelligence tool where we may have a dashboard. And again, that will give us some insights into what's happening. So this data is being streamed in. We can do some analysis of this fast data. Equally, we could apply it with some historical data that we have saved elsewhere, and then we can get some useful insights into what that data is actually telling us. So, as I mentioned before, so if we go back to our dashboard and we sort of scroll down a little bit now and have a look, there we can see previously all of this showed zeros, but here we can see now we've got data that's sort of increasing 2K, 2.6K, and there you can see in real time it's sort of updating. So these caches are kind of being filled in. Okay. A couple of other points then, very quickly. So where to get Ignite then? So ignite.apache.org. This is the place to go. So it's possible to do the downloads here. You can download the source code. You can build from source. There are binary releases as well. And then if you are particularly interested, for example, in running in Docker or cloud environments, there are some images available there. As I said, the community is very active. Mailing lists, questions that you can ask, screencasts available as well. Lots of other information that is very useful. The documentation is sort of great. I've been using it myself for the past couple of months in terms of learning the technology, being able to run some of the samples, and that's been very helpful to me. And again, use cases as well in terms of looking at some of the capabilities. As I mentioned in the webinar as well. So GridGain provides additional support and capabilities at an enterprise level. And if you need those, please do contact us. We'll be happy to discuss those with you. Finally, just to wrap up then, I did mention my colleague Dennis Magda. So if you're interested in looking at the code specifically for that short demo that I showed you, then it's available on his GitHub account. So github.com/dmagda. And there you can see the Ignite Spark IoT. Okay, so all of the code is available there. You can drill down and have a look at the Java code in your own time. And again, adapt it to your needs. And it's very simple to run as well. Okay, so I think that's more or less what I wanted to cover. So just, I think, switch back to the slides. So Alicia, if we have any questions, I'm very happy to take those now, and I'll do my very best to answer those.
Okay, great. There are some questions. Let me go ahead and read them to you. Let me know if you need me to repeat them. Okay, so the first question is, if I need to use Ignite as a data grid or cache on top of a database and perform transactions, How does it work?
Great question. Thank you very much. And in fact, you and I will remember that the webinar that I did a few months back discussed this very subject. So we've got a screencast webinar that we talked about transactions. So the way this works is that Ignite will treat the database system as the source of truth. So it will always commit to the database system first, okay? That's how it works. So in the event, for example, that you're using Ignite purely in memory and say the cluster goes down for some reason, then the data will definitely be stored to the relational system, which will be under transaction control anyway. The cluster can be brought up, we can read again from the relational system, and then be able to build whatever we need to build within memory. So this is actually something that we covered some months ago, and I think what I can certainly do is in the slide deck, I can add this as a link to the end in terms of the actual webinar that we did on this.
Fantastic. Okay, the next question is, how do I mix in memory with disk, and what are the advantages of using memory only or a mix or disk only?
Okay, so Ignite is very flexible. So in the high-level graphic that I showed almost at the start of the presentation, we see that it provides its own kind of persistence mechanism, and it manages that for you. So all of the data, I mean, if you have it enabled, the way it works is that all of the data that Ignite has is stored on disk. Some of that data will then be held in memory. And that goes for indexes as well. For example, if you're using something like SQL and you're using indexes on tables. So this is something that Ignite manages for you in terms of the persistence and paging in data as it's required in memory if you're running some queries or you're trying to do some work across the cluster. So this is something that as a developer you have to worry less about. Equally, if you're working with sort of third-party solutions, you may be working, say, with Postgres or MySQL or something like that, or HDFS or NoSQL. Again, the ability to read data, connect to these systems, read it into memory. The benefit, I think, that comes from just having everything in memory is, of course, things will just run at lightning speed. You know, once the data are cached, and we all know, you know, if I have a laptop, it's got a certain level of memory. If that memory fills up, I find my machine is running very sluggishly, and this is periodically I have to check, run a sort of program to be able to free some of that memory up for me. Ignite will manage all of that for you. I mean, this is the key thing. So the benefit of running things memory is, of course, you get things at memory speeds, you know, extremely fast, lightning fast. Where you've got persistence and you're able, and you have a need to store things beyond the lifetime of the process that created it, creates obviously some issues and some complications. But again, Ignite has very intelligent memory management capabilities. It can page things in and out for you, and based on a variety of sort of use case patterns, you know, least recently used and so on. So it can flush things out, but it will try to keep things in memory as much as possible. So memory is great. The more the merrier. Okay, it's going to be better for you if you can add as much memory as possible. If you need some persistence capabilities, that's a simple switch that you can make in Ignite. It will manage that for you as well. Save things to disk in the event there's something really catastrophic, cluster goes down, you know, that data will still be saved. And then the mixture of the two, obviously, this is something that Ignite will manage for you. And then again, there is some references that we have available. Again, I can include those at the end of the slide deck if that will be helpful to people.
Okay, and we have another question, and that is, can I use Ignite as a cache for all patient interactions and data, and then also use it with or without Spark to personalize, such as suggest appointments or payment plans when a plan makes more sense?
Okay, so Ignite and Spark are complementary technologies. They will work very well together. And the short demo that I showed you there that my colleague Dennis Magda built, Dennis actually has Spark running as part of that. And it's certainly possible that the two technologies can work well together. And yes, I see, you know, there's many, I think, opportunities to use Ignite for some of the healthcare patient data that we talked about, storing electronic healthcare records, whether you choose to just cache that entirely in memory or if you want to use some of its persistence capabilities, that's perfectly possible. I mean, it really depends on what level of interaction you want. If you want, and if we look back again at the second case study, we're talking about the sort of PPO, they wanted sort of fairly strict and stringent SLAs. They wanted to bring down processing time from sort of 15 seconds down to 1 second in one case. And again, they're porting the data into Ignite. The business logic will come as well. And in the second application, it's converting a batch process to something that's a little bit more interactive, but again, they've got fairly stringent SLAs, bringing it down to a couple of seconds. So I think it's perfectly possible to do this and very easy to combine these two technologies together as well. Ignite has adapters and connectors for a lot of these streaming technologies. Spark happens to be one of them. And it can work with Spark in other ways as well. So for example, it can, if you're working at the level of RDDs, it will work perfectly well with those. And there is a data frame support coming as well very shortly. So there shouldn't be any problem. But I guess it's really the division of work that perhaps the questioner is really interested in. How can you, what is the part of the work that Spark will need to do versus what Ignite will do? Well, Ignite can do a lot. So it can certainly do the caching. It can offer persistence. It will provide robust SQL. It can do machine learning, the computation, the parallelism. There's a lot of other capabilities that we didn't have time to discuss today. For example, co-location. So one of the things that might be very useful in Ignite is associating or storing patient data that's related in some way. So we could have, for example, a healthcare provider storing data based upon a particular city or a particular region, or they could be done on sort of particular medical conditions. There's a range of criteria that they may decide. But again, it depends on how you architect it, what sort of queries you want to run. There's many ways that you can build this. It's a kind of a tough question to answer. I think would need to understand a little bit about more of the use case in terms of what the questioner wanted to do. But there's a lot of flexibility there and plenty of scope in terms of how you can build this. I don't see a big problem there.
Great. And audience, just for your information, Akmal is going to come back, do more presentations for us and go more deeply into Spark and Apache Ignite and GridGain, probably in either January or February. So be sure to check gridgain.com for our upcoming webinar schedule, which I update weekly. With that said, we're at the top of the hour and there are no more questions. So I would like to thank you, Akmal, for today's presentation. And audience, I hope that you found it both pleasant, I did, as well as informative. And we hope to see you on a future show. So Akmal, thank you again very much.
Thank you very much, Alexia. Thank you, everyone, for joining today. I appreciate, your time is valuable and we really appreciate it. Hope it's been useful for you. And again, I'll get the slides out to you very shortly, Alicia, and I will add some additional references as per the questions and some of the additional sort of areas that I covered through the presentation.
Oh, great. Thank you so much, everyone. Have a great day or evening.
Thank you.